In this video, we're going to discuss how to print out all the anagrams of a word. That is, every possible ordering of the letters of the word. In this case, it isn't immediately apparent how to solve this with loops, but as we walk through solving this problem with recursion, you'll see that it leads to a short and elegant solution. The first rule of recursion states, I can solve at least one small problem. This forms the base case. Thinking about the anagram problem, the simplest word to print all of the anagrams for would be one letter long. The word itself is the one solution. So the base case of our recursion will be when the length of the word is 1. The second rule of recursion is, if I can solve a slightly smaller problem, I can solve this one. Consider the word teal. In this case, we'd want to print all of the anagrams of a word of length 4. How could we make the problem smaller? Well, we could remove a letter, leaving eel. If we were able to get all the anagrams for eel, we could put T on the front and have a bunch of anagrams for teal. That's not enough, though, as we miss anagrams like late or leet. But what if we did the same thing removing L from the word? We could then put L on the front of all the anagrams of T. That gets us halfway there. If we repeat this for every letter in the word, we can make anagrams of a 4-letter word by prepending a letter to the solution of all the anagrams for 4 different 3-letter words. Recursion will take care of the rest. Each 3-letter word gets anagrams by putting a letter on the front of anagrams of 2-letter words. Each 2-letter word gets anagrams by putting a letter on the front of anagrams of 1-letter words. Each 1-letter word is its only anagram, so the process will stop. Now let's talk about how to translate this into code. Since we decided to add letters to the beginning, we'll have a prefix parameter in addition to the parameter for the word. The base case, the one small problem we can solve directly, is when the word is 1 letter long. In this case, we print out the prefix and the word. The recursive case is more complex. In the else, we know that the word is at least 2 letters long, so we add a recursive call, removing the first letter from the word. So if the word is n letters long, it will print out all the anagrams for the word with the last n-1 characters, with the first letter as a prefix, plus any prefix that we already had. We do the same thing for the last letter of the word. We add the last letter to the prefix and do a recursive call with the first n-1 characters of word. In the middle loop, through the middle letters from 1 to word length -2. In each case, we add that letter to the prefix and remove it from the word. We remove it from the word by concatenating the substring of all letters before the ith letter with a substring of all letters from i+1 to the end of the string. Now we're done. We have a fairly compact method that prints out all the anagrams of a word. And actually, because of the way slices work in Go, we can do everything in the loop because word bracket 0:0 will be the empty string. To hide the prefix parameter from the user, we can add a small method which calls our helper method, initializing prefix to the empty string.